Okay, so we've got a lovely little C1 question here, and it goes, solve the simultaneous equations, and you're given two simultaneous equations to solve there. Now the first thing that I would do is I would rearrange this to get either x equals, or you could use y equals, and then substitute that in, okay, to this part of the equation over here, okay. Then you have to keep your nerve, expand your brackets, collect your like terms together, and you end up with a lovely quadratic, okay, from which you can solve to get your values of y. Once you've got your values of y, don't forget the final move is to then substitute them back into one of your original equations. Now I would use this one, okay, because it's a bit simpler, to get your values of x. And then the question goes on to say, find the constants a and b such that for all values of x, x squared plus 6x plus 20 is equal to x plus a all squared plus b. Now as soon as you see something like this has got to tell you you're going to need to use your completing the square, okay? And when you use completing the square, we use the coefficient of the b term, which is your singular x term here, okay? And you halve it to get your value a. So here we've got 6x, so we halve that, x has got to be 3. You pop that into your brackets, and the brackets, remember, is squared, so then the next thing to do is to expand out that brackets and see what it gives you. It gives you x squared, tick, we need that. It gives you 6x, perfect, we need that as well. Oh, but it gives you plus 9. So we need to do something to make this 9 up to the 20 in the first term there. We need x squared plus 6x plus 20, like I've just mentioned, okay? And to get what we actually need, we've got to add an additional 20 minus 9, we've got to add 11 to the expansion of this bracket. So that gives us x squared plus x plus 3 all squared plus the 11. So A is 3 and B is 11. The question then moves on and it says, hence, state the least value for x squared plus 6x plus 20 and state the value for x for which this least value occurs. Okay? Instead of using this, we're going to use our new x plus 3 squared plus 11. Okay? And we're going to use the techniques we learned when we looked at transformation of graphs. Okay? Starting here. Here is my typical x squared graph, okay, and that's what I'm going to start with, and I'm going to transform that graph to give me my answer. The first thing I'm going to do is I'm going to look at this, okay, and I've got x plus 3. Now it's inside the brackets, therefore it's inside the function. If it's inside the function, it affects my graph, okay, in the x direction. And when things happen in the x direction, it happens in the opposite way you'd think. Okay, so it's x plus 3, which means that my graph is then going to move, okay, it starts here, it's going to move 3 units, 1, 2, 3, okay, 3 units in that negative x direction. So this is the first place, if you like, this is where it's going to go to, right? Then I'm going to deal with this plus 11. Now this plus 11 is outside the function to do with x, so it's outside. So that means it affects my graph in the y direction. When things affect the graph in the y direction, they affect them as you'd expect, okay? So it's plus 11. So for every value of y on this, I'm going to add 11. So what my graph does is it then moves up to here, okay? And that point there, that lowest point, okay, instead of 0, it becomes 11. Okay, so using those two transformations of my graph, okay, I get to where my graph is going to look like, and I say the least value of x squared plus 6x plus 20 is my lowest value of y, okay, and that is 11. So y is 11, okay, and what value of x does it occur for? Well, it's moved up from this point here, okay, where x is actually minus 3. So x is minus 3, okay. So the coordinates of my point are minus 3, 11. Then the last part of the question goes on to say, write down the greatest value of 1 over x squared plus 6x plus 20. Now this is a fraction, and the way fractions work, so fractions are the largest, okay, when the denominator of the fraction is the smallest, okay. So what we want to do is we want to think about when we can make that as small as possible. Now luckily we've already graphed that here, okay, that's x squared plus 6x plus 20, and that is its smallest point when y is 11. So actually, this fraction is going to be the greatest when we replace this, okay, by that y equals 11. So The lowest value of y is 11, therefore the greatest value of this fraction is going to be 1 over 11. Thank you.